Hello viewers, welcome back to my channel Experience Physics. So in this class, we are going to solve some problems under the topic drift velocity and its relevant equations. Not only drift velocity, mobility, and current density, so these are the topics we are going to the problems in these topics we are going to solve in this video lecture, right? So the concept of drift velocity already we have discussed in the previous video lecture. Viewers, if you have not watched that video, you please go and watch it and you come back here, right? Unless otherwise you know the concept of drift velocity, mobility, current density, current resistance, resistivity. In fact, for resistivity we are going to make another video. So in this video lecture we are going to see these three subtopics only, right? So if you have not watched that video for the concepts, you please go and watch it, right? Then only it will be very easy for you to solve the few examples here, right? So anyhow, we will have a quick recap what we have discussed in the previous video lecture. Drift velocity. Drift velocity, we wrote it using the letter Vd. Any velocity is acceleration into time, acceleration force by mass, force Coulomb force. So already I have told in that video lecture, whenever you see these two E's together, you must recall force. This is charge, this is electric field, right? Whenever you see it, you must recall the Coulomb's force. F is equal to QE. Instead of Q, we are writing small letter E, right? So this is force upon mass. Then for the time, we had the tau, relaxation time. This is the equation for drift velocity. Then from here, we found what is I, the current. Once velocity is there, the electrons will start moving. If the electrons start moving, current will be there, right? I is equal to, we found it is ENA Vd. It is simply I is equal to Q by T. In our case, it is Ne by T, this N. Total number of electrons, capital letter N. If I use the small letter n, this is free electron density, n into volume. Free electron density into volume will give you the capital letter n, total number of electrons in the entire conductor, into E by T. So this is volume, we will write area of the cross section of the conductor and the length of the conductor, then E by T. This L by T, meter per second, this is nothing but Vd. L by T is Vd. Then this is ENA Vd. Yes. Then I by A is equal to current density, ENA. This is written as J. So J is equal to sigma E also we have found. Conductivity of the material, J is equal to J, current density, current upon area, En, this is Vd. Yes. Yes. Current density En Vd, then current density J is equal to sigma E. Sigma is the conductivity of the material, E electric field applied, yes, J current density. Then mobility, from here let me write Vd is equal to E tau by M into E. I am grouping tau here, right? E constant, charge on electron, M constant, mass of electron, tau. If you keep the temperature constant, if T is constant, tau is also constant. So tau can also be made as constant if you keep the temperature constant. Please remember, under the topic drift velocity, we always assume temperature is constant. We want to change the temperature value, right? Under the topic drift velocity, you can assume the temperature is constant. So this will be a constant. This constant is written as mu, another constant. So this is known as mobility. Mobility means how quickly the electrons are moving inside the conductor, right? Upon the application of one electric field. If you apply some electric field to your conductor, how quickly the electrons are going to move. So this is one constant mu. It is material dependent because tau, not only the temperature, it also depends on the material, whether copper or aluminum, right? So we want to change the material always, right? We will take only one material, and also we are keeping the temperature constant, so we can assume this tau is also constant. Vd is equal to mu e. Vd is equal to mu e. Right. I is equal to En AVD. I is equal to ENA EE by M into tau. Let us group them. N E square tau by M, N E square tau by M, A into E is equal to N E square tau by M. Instead of E, let me write V by L. E is written as V by L, right? So electric field, we are applying one electrical voltage to the entire circuit. The length of the conductor, it is taken as L. So V by L is nothing but your E, right? Then V by I, voltage by I. Yes, V by I. According to Ohm's law, V by I is equal to R. This is M over N E square tau. This is one constant. Mass of electron. This is free electron density. E charge. Tau relaxation time. If you keep the temperature constant, tau will become constant, right? So this will be another constant, rho. R is equal to rho L by A. Resistance of the material, right? So V by I is equal to R. This is under Ohm's law. Ohm's law, we will make another video, right? We will deeply study about Ohm's law and relevant equation, and we also try to solve some problems, right? R is equal to rho L by A, right? If I make L is equal to 1 and A is equal to 1 meter, A is 1 meter square, 1 by 1 will get cancelled, then I will get R is equal to rho. So this is also we have seen elaborately in the previous video. R is equal to rho. So it is nothing but the resistivity of the material. This is the resistance of the material. Rho is the resistivity of the material or specific resistance of the material, right? So dimensions will not come here. In the case of rho, dimensions, L we cancelled, A not cancelled. We have assumed its value is 1. Area is also 1. For 1 meter length and 1 meter square cross sectional area, what is the resistance value? That is known as resistivity of the material, right? So R is equal to rho. Its unit is, rho unit is ohm meter, right? So these are all the things we have discussed already, right? Then from here we saw conductivity. I by A is equal to J, right? Conductivity also we have seen. But here we are going to solve the problems in current density, mobility and drift velocity only, right? So let us take the problems one by one. Yes. Drift velocity of electrons is due to motion of conduction electrons due to random collisions. Random collisions will not give you a specific direction. For the velocity, for the electrons to have a single unified direction of motion only. So random collisions, right? It won't give the drift velocity. Motion of conduction. Conduction electron means free electrons. So conduction electrons. The free electrons is responsible for the conduction of current, right? So conduction electrons due to electric field E. Yes, this is correct. This answer, repulsion to the conduction electrons due to inner electrons. Inner electrons won't repel the free electrons. Free electrons have come out of the atoms, right? They have liberated from the atom. So this is not true. And collision of conduction electrons with each other. Collision, no, it doesn't occur, right? We have discussed in the previous lecture also. Collision won't occur between electron to electron. They have negative charge. They will repel, right? They won't collide. It won't attract, right? The collision will occur between an electron and positive ion only, right? So this is the answer. Motion of conduction electrons due to electric field E. The drift speed of electron in any conductor is of the order of drift speed. Drift means to move slowly. To move slowly. This is the definition for the drift. If you take the dictionary, you can see the word to move slowly under the aid of external force, right? It can't move on its own under the aid of external force, right? So to move slowly. So drift speed is 10 power 2. It is a big number, 100. So this is 10 power minus 2 centimeter per second, right? Or 10 power minus 4 meter per second. This is correct. 10 power 0 is 1 meter per second. Wrong. 10 power minus 2 centimeter per second. The velocity of charge carriers of current about 1 ampere. 1 ampere means 1 coulomb per 1 second. This is 1 ampere. In a metal, under normal condition is of the order of velocity of charge carriers. Charge carriers are our free electrons. In a metal, under normal condition is of the order of, similar to the previous problem, the same problem. A fraction of millimeter per second, it may be true. Velocity of light, this is 3 into 10 to the power of 8. Drift velocity won't go in this speed. Several thousand meters per second, no. A few hundred meters. So option A is correct. Fraction of millimeter per second. Very slowly the electrons are moving. Which of the following characteristics of electrons determine the current in a conductor? Which of the following characteristics of electrons determine the current in a conductor? Drift velocity alone. Yes. Drift velocity is responsible for the constitution of current. Thermal velocity alone, no. Thermal velocity, the average value is 0. Both drift velocity and thermal velocity should not come. This is neither drift nor thermal. This is absolutely wrong. Drift velocity only. Yes, right. The drift velocity does not depend on cross-sectional area A, length of the wire L, number of electrons per centimeter cube N. In fact, this is per meter cube, right? So concept only we are going to discuss, not any numerical value. So let me write N, magnitude of current. So we want a equation relating these things with the drift velocity. Yes, Vd is equal to I upon ENA. Magnitude of current, yes, it depends. Cross section of the wire, yes, it depends. Number of electrons per centimeter cube, N, yes, it depends. This is also constant, right? The length of the wire is the right answer because length does not appear in this equation. So drift velocity does not depend on the length of the wire. A wire has non-uniform cross-section as shown in figure. Yes, it is increasing from A to B. The cross-sectional area is increasing. A steady current is flowing through it. Okay. Then the drift speed of the electrons, Vd is what? Cross-sectional area is increasing. Is constant throughout the wire, decreases from A to B, increases from A to B, varies randomly. These are the options given. The drift speed, Vd, is equal to I upon ENA. Steady current. This is steady current. I constant. E always constant, N is also constant. Material we have not changed. Vd is inversely proportional to area. So Vd will be more, Vd will be less. Vd value. Here they have to move very quickly into that area. They have to pass very quickly. This is very narrow. Right? Here the Vd will be less. Right? So it is decreases from E2. Vd value is decrease. Vd decreases from A to B. Option B is right. Decreases from A to B. For the given conductor, the drift speed of electrons at cross section 1, 2 and 3 are V1, V1, V2, V3. Then which of the given option is best suited? V1, V2, V3. Similar to the same problem. Cross sectional area determines the speed. More speed, less speed. This is in between 2 and 3. This is very small area of cross section. They have to move fast. More speed, less speed. This is in between 2 and 3. So V1 is equal to V2 is equal to V3. Wrong. V2 is greater than V1. Yes. But V3 is greater than wrong. V3 will be the lowest value. V2 is greater than V1. Okay. V3 is less than V1. Yes, this is correct. V2 is greater than V3 is greater than wrong. Yes. Suppose the drift velocity Vd in a material varied with the applied electric field as Vd is proportional to square root E. This is the condition they are giving. Then the VI graph for a wire made of such a material is best given by. Right. All the options are given in graphical manner. We have to find which one is best suited. Right. So first we have to see what relationship is they are making between V and I. So y-axis V, x-axis I. Right. This is a parabola. So V is proportional to I square. This is V is proportional to I. Straight line equation mx plus c proportional to I. This is V is constant. V varying, I is constant. This line goes vertically, so I is constant irrespective of changes in V. Then this one is V is proportional to, this is exponential curve, V is proportional to increasing, so plus I. So V is proportional to EI, V is proportional to I square, V is proportional to I is equal to constant. Right, you know the equation for the shape of the curves, right? But here it is given velocity with respect to E, not between voltage and current. So we have to change the velocity and electric field with voltage and currents, right? We have to find what relationship velocity is making with voltage or current. Similarly, E is making voltage or current. Then we have to replace the voltage and current with the velocity and E. In fact, this is also one assumption. Vd is actually not proportional to root E. Vd is proportional to E only. This is our formula. Vd is equal to EE by tau into EE by M into tau. EE by M into tau. So this is directly proportional. Vd is in fact directly proportional, but they are giving this condition. Vd is, if you assume Vd is proportional to root E, what is the shape of the curve between voltage and current, right? So we have to develop, or we have to find an alternate equation replacing Vd and E with voltage and current, right? Then we can choose our best answer. Vd is proportional to root E. Vd has Direct relationship with E. Look at this formula. Vd is equal to E by m into tau. E constant, m constant, tau if you keep the temperature, that is also going to be constant. So Vd is directly proportional to E. Vd is equal to E by m into tau. From here I will write Vd is proportional to E. So this formula, if I relate, that is fine. But for E, I can't bring the current here. So I am not using this formula. Instead, I will use the current formula here. Because I also we can relate with Vd. I is equal to ENA Vd. So I is directly proportional to Vd. Because Vd is responsible for the flow of current. Direct relationship. Vd is responsible for the flow of current. So wherever I find I can replace with Vd, right? Second one, E. E is equal to voltage per length of the conductor. E is equal to V by L. Voltage per meter, its unit is voltage per length of the conductor. So V is proportional to E. E is proportional to V. Length of the conductor, it is going to be constant. So instead of I will write instead of I will write Vd yes. Instead of V, I will write E. So the y-axis becomes E and the x-axis becomes I. E and Vd, E and Vd, everything is between E and Vd only, right? What we have developed, Vd is proportional to root E. This is what we are given the condition. Vd is proportional to square root E. Let me take square root both sides. Vd square is proportional to E. Instead of Vd, what we are having? I. In the given example. So this is I square. Instead of E, this is V. So V must be proportional to I square. That is the correct answer. V proportional to I square. Option A. So two things we have made. One is, for the given condition, we have found the equivalent voltage and current, right? Number two, we have developed this Vd proportional to root E with V is proportional to I square. Number one, we have changed Vd and E with current and voltages. Then we have found this equivalent condition. Vd is proportional to root E, V is proportional to I square. So using this condition, we found the correct graph, right? Fine. The total momentum of electrons in a straight wire of length 1000 meter carrying a current of 1.6 ampere. Momentum is asked. Momentum, we write P is equal to mass times velocity. Mass of electron we know. Mass of electron m is equal to 9.1 into 10 to the power of minus 31 kg. Such a low mass it possesses. Velocity, we need velocity. If velocity is known, we can directly apply the formula and get the result. Velocity, what is the unit of it? Meter per second. Meter 1000. Second, no. Time is not available. Find the time. Somewhere bring the time. What is the other data which is available? Current. Current and time can be related. I is equal to Q by T or E by T. Yes. From here, let me take what is time is equal to E into I. Time is equal to E into I. Right. So now velocity we can write. P is equal to mass time velocity, mass 9 Let me write the formula first. Yes. Mass time velocity, mass is available, velocity L is available. Instead of T, we have EI. So this is I by E. T is equal to E by I. Yes. Mass 9.1 into 10 to the power of minus 31, L 1000 meter, I 1.6. This is E. E is equal to 1.6 into 10 to the power of minus 19. 1.6 can be removed. This is minus 19 plus 19 plus 22, 3 zeros, 19 plus 3, 22, 31 minus 22, 9. So the answer is 10 to the power of minus 10 to the power of minus 9. The value is 9.1. Yes. 1.6 removed, 3 zeros, 19 minus 16, right? This is 19 plus 3, it is 22, it is minus 9. 9.1 into 10 to the power of minus 15 minus 31 minus 9. Yes, option C is correct. Yes. Velocity is not directly given, length they are giving, time from current we are taking the time. Two conductors A and B of the same material having radii in the ratio 1:2 and carry currents in the ratio 4:1. The ratio of drift speed Vd. Two conductors A and B. Yes. Two conductors A and B, same material is same, having radii R1 by R2, radii is equal to 1:2. Carry currents in the ratio I1 by I2, 4:1. The ratio of drift speed of electrons in A and B, Vd1 by Vd2. This ratio is asked. Instead of A and B, I have used the suffixes, suffix 1 and 2, right? R1 means A, R2, radius of A, radius of B, right? So please remember, in this type of problems, whenever you see the word radius, immediately A must come, area, right? So Vd, from I we are going to write Vd. Vd is equal to I upon ENA. E constant, N constant, same material. So Vd is proportional to I by A only. So already I told you, whenever you see the word radius, you must recall, you must connect the area, right? In this type of problems, area is equal to pi r square. So A is proportional to r square. So I will rewrite Vd is proportional to I upon r square, right? So easily we can find the ratio. Vd1 by Vd2 is equal to I1 by R1 square upon I2 by R2 square. This can be rewritten as I1 by I2 multiplied by R2 by R1 square. This is I1 by I2, the ratio is 4:1 multiplied by R2 by R1, R2 by R, 2 by 1. So this is square. So 2 by 1 square. This will be 4 by 1 into 4 by 1 is equal to 16 by 1 is the answer. 16 is to 1. Option A. Radius. Whenever you see the word radius, you immediately bring the area. Area can be related with current density. Yes. I by A is area. Even otherwise, we can use this formula. VD is equal to E and A, right? Once radius is converted into area in this type of problems, we can go any way which will be required, right? So next problem. The drift velocity of electrons for a conductor connected in an electrical circuit is VD. The conductor is now replaced by another conductor with same material. Replaced by another conductor, same material and same length, but double the area of cross section. Again, area of cross section is coming. The applied voltage remains same. Material same, length same, voltage same. Material same, same material. You are replacing in an electrical circuit with the same material but different conductor. Its area of cross section is raised. Length has not been raised, right? The drift velocity of electrons, VD. So let me have the two conductors first. This conductor 1, length same, conductor 2, length same, but the cross sectional area is double the size, double the area of cross section. If it is A, then it will be 2A. Length does not change. Length remains same. The applied voltage remains same, yes. V. Same voltage we are giving for this conductor. The drift velocity of electrons. This VD, this is given as VD. For the first conductor, it is VD. What will be the drift velocity for the second conductor? Let it be VD dash. VD dash. The drift velocity of electrons will be after the replacement. First one is replaced by the second conductor with the same length, same material, but double the cross-sectional area, right? V same, L same, V same, L same, right? VD is equal to EE, or otherwise I can use this formula. This formula also we can use. VD is equal to mu into E, mu mobility. If you keep the temperature constant, all are going to be constant, E, tau, M, right? That is what we have discussed in the previous lecture. In the recap also I have discussed. VD is equal to mu E. Mu is a constant, material dependent. For copper, its value is 1. For aluminum, its value is different, right? Material to material only, the mobility is going to be changed. So it is a constant. VD is equal to mu E. So VD is proportional to E. E is equal to V by L. E by L, V by L. V is same, L also same. In both the cases, VD will be same. VD1 is equal to mu E, VD2 is equal to also mu E. Mu is constant for the given same material. Same material. Material we have not changed. So the answer is VD. Then the area of cross section, what it makes? What it makes? Area of cross section. we know R is equal to rho L by A. R is equal to rho L by A. Material we have not changed. So rho is constant. L is also constant. R is proportional to 1 by A. If we increase A, double the area of cross section. If we increase A, the R is going to decrease. If area is increased, the resistance is going to decrease. If R is decreased, the current will increase. Right? The VD is equal to I upon ENA. Area is increasing, thereby resistance is decreasing, then current is increasing. Right? So if area increases, current is also increasing. If the size is doubled, the current value will also be doubled. Current is also doubled, area is also doubled. It will be cancelled. Again, I divided by ENA will remain. Right? That is why VD does not change. If V and L are constant, it is going to be the same value. Right? So this formula is easy. We can apply this formula to find the result. Right? This is the concept. How if A affects drift velocity of electrons? No, it won't affect in this case. It won't affect. The drift speed of free electrons in a conductor is 0.1 mm per second. 0.1 mm per second. And the electric field in the conductor is 5 times 10 to the power of minus 2 voltage per meter. The mobility of the free electron is, yes, directly we can apply the formula and tell the result. Mobility is equal to VD upon E. VD is 0.1 millimeter per second. This should be converted into meter per second. 0.1 into 10 to the power of minus 3 meter per second. Or I can write 1 into 10 to the power of minus 4. Yes. VD is equal to 1 into 10 to the power minus 4 divided by 5 into 10 to the power of minus 2. 1 by 5 is 0.2. This 2 will go up. 0.2 into 10 to the power of minus 2. All are in terms of 10 to the power of minus 3. So 2 into 10 to the power of minus 3 is the answer. 2 into 10 to the power of minus 3. So 1, 1.5, 2, 2.5. 2 into 10 to the power of minus 3 is the answer. The potential difference of 5 voltage is maintained between the ends of a conductor of length 20 centimeter. The drift velocity of electrons is 10 times 10 to the power minus 6 meter per second. The mobility, again mobility problem. Potential difference of 5 voltage is applied to a conductor of length 20 centimeter. This is 5 voltage, this is 20 centimeter. The drift velocity is also given, VD. 10 times 10 power minus 6 meter per second. The mobility is in question. The direct formula, mu E is equal to VD by E. E V by L. Voltage is available, L is available, length is available. Yes. So VD by V by L is equal to VDL by V. VD is 10 into 10 to the power of minus 6. Length is 20 centimeter. Convert it into meter, 0.2 meter. Divided by voltage, applied voltage is 5. So 5, 10, this is 2. 2 into 0.2, 0.4 into 10 to the power of minus 6. This is the answer. 2, 6, 4, 10 to the power of minus 7. Yes. 4 into 10 to the power of minus 7. The dimensional formula of mobility is dimensional formula for mobility. Let us start from the basics. From the fundamentals we will write. Mu, we will write it as Vd upon V. For Vd, meter per second. Meter per second for Vd. For E, we will write it as force by Q. Coulomb's force by Q. Force, we will write it as mass times acceleration. Q, I is equal to Q by T. Q is equal to IT. I current multiplied by time. Ampere is one of the fundamental unit. That is why we are bringing current here. Mass M, acceleration meter per second, current ampere, this is T. So this will be M L T minus 3 A inverse. This is for E. M L T minus 3 A. Right. We will put here LT minus 1. So this is M L T minus 3 A inverse. This will become A M inverse. L will be cancelled. Minus 3, it is plus 3. It is T square T power 2 A inverse A. M inverse L O. This will be the answer. M inverse L O, M inverse L O, M inverse L O T square A, right? M inverse L power O T square A. Dimensional quantity. From the fundamentals only we are deriving. What is the relationship between electric field intensity, current density and specific resistance? E J rho. J is equal to sigma E. That is the formula. Sigma and rho are inversely proportional. So 1 by rho E. J is equal to 1 by rho E. Yes. First one. E is equal to rho by J, wrong. J is equal to rho E. J is equal to sigma E. It's also wrong. J is equal to 1 by rho E. Directly apply the formula and convert it. Similar problem. The electric field E, current density and conductivity. Here conductivity. So J is equal to sigma E. J is equal, all are sigmas. So sigma is equal to J by E. Sigma is equal to E by J, J by E. Option B. J is equal to sigma E, sigma is equal to J by E. This is sigma is equal to I by J E. Wrong, wrong, wrong. In the equation AB is equal to C, where A is current density, C is electric field, then B is what? AB is equal to C. A is current density. B is what? C is electric field. If you assume A is equal to J and C is equal to E, then what is B? Let us write what is B. C by A. Then if you replace C with E and A with J, what has to come here? J is equal to sigma E. E by J you find. E by J is equal to 1 by sigma. This is the original equation. J is equal to sigma E. E by J I am finding. To relate this given equation, E by J is equal to 1 by sigma. 1 by sigma is resistivity. Yes. 1 by sigma is resistivity. Reciprocal of conductivity is resistivity. Conductivity wrong, potential difference, resistance wrong. Right. A conductor carries a current of 50 microamperes. If the area of cross section of the conductor is 50 millimeters square, then the value of current density, direct question, J is equal to I by A. Ampere per meter square. Ampere is given, meter square is also given. In fact, millimeter square, we can easily convert it into meter square. 50 into 10 to the power of minus 6 meter square. So I is 50 microamperes. Micro also 10 to the power minus 6. This is also 50 into 10 to the power of minus 6. The answer is 1. 5241. A steady current flows in a metallic conductor of non-uniform cross section as shown. The quantity as well as quantities that remain constant along the length of the conductor is. Steady current flows. So I is constant. Area of cross section is varying. What are the quantities which are going to be constant? The options are current only, current and current density. Current should be constant. Yes. The problem itself, it is given steady current. So current and current density, we have to check the current density. Current density J is equal to I by A. If area of cross section is changing, current density will change. So this will not be the answer. Current and drift velocity of electrons. Drift velocity, I is equal to ENA VD. I is constant. So VD is equal to I by ENA. I is constant, E constant, N constant. The VD is proportional to 1 by A. If area of cross section changes, drift velocity will also changing. So this is also wrong. Current density and drift velocity, current density should not come, right? So current only, the quantity or quantities, right? They are just misguiding you. Quantities. They have included the word quantities to confuse you. But current only constant, right? A constant current I is flowing along the length of the conductor of variable cross section as shown in the figure. The quantity which does not depend upon the area of cross section. What are the quantities which does not depend upon the area of cross section? Electron density, this is N. Current density, this is J. Drift velocity, VD, and electric field E. Area of cross section is changing, current is constant. We have to relate area with these quantities, right? Current is constant. VD is equal to I upon ENA. Current is constant, E constant, N constant. VD is inversely proportional to area. VD is inversely proportional to area. Area of cross section, if it changes, VD will change. But the question is, does not depend. So, VD, the answer C is not the correct one, right? N, electron density, it depends on the material, what you are using, right? It is material dependent. So, A should not be the answer. The quantity does not depend on, yes. N is constant, yes. In fact, N is constant, right? Does not. The question is does not, yes. So, N is the answer. Sorry. N is the answer. It does not depend on area of cross section, right? We will check other two quantities also. J, right? J is equal to I by A. I constant, so J is inversely proportional to A, right? Area is changing, so J must change. Electric field E, we will check this answer also. J is equal to sigma E. Yes, J is equal to sigma E. J is equal to I by A, sigma E. I constant, sigma is also constant, material dependent, conductivity. So E is directly proportional to 1 by A. E is directly proportional to 1 by A, inversely proportional to A. So this is also changing. Right? N only does not change. Right? So copper one value, aluminum one value. Right? So free electron density is the constant in this problem. Right? It does not depend on the cross-sectional area. Right? If J and E are current density and electric field respectively inside a current carrying conductor at an instant, then J cross E, cross product, J and E, what will be the result? Cross product definition, magnitude of J multiplied with magnitude of E and sin theta, angle between them, J, E, sin theta. Then its a unit vector must also come, but I have not written it, unit vector, because this will be, the answer will also be a vector. Because this is magnitude, this is magnitude, this is magnitude. Unit vector we must write. J cross E. Right. Let us take one conductor. I am applying some voltage to develop E. Right. This is V and this is L. V by L is giving me E. E lines. These are E lines. Then the applied electric field pull all the electron towards the positive terminal of the battery. In the concept video, we have discussed it elaborately, right? So all the electrons are moving in this direction, but the conventional current is moving in this direction. I. Electron movement is moving in this direction, conventional current is moving in the opposite direction. The conventional current will flow in this direction. This is I direction. Inside the conductor, I. So movement of positive charges also people tell. So this is the direction of current. What is the angle between E and I? Both lines are parallel. Angle between E and I is 0. Sin theta, sin 0 is 0. So the answer will be 0. Positive, negative, 0. Maybe positive or negative, 0. Yes. A current of 5 ampere passes through a copper conductor of rho 1.7 times 10 to the power of minus 8 ohm meter, and the radius of cross section is 5 mm. Find the mobility of charges if the drift velocity is 1.1 times 10 to the power of minus 3 meter per second. Rho is available, radius, right? I have already told you, whenever you see the word radius, area must come into your mind, right? So this value we can make it as meter. Mu is in question Vd, right? Mu is equal to Vd by E, direct formula. Vd is available 1.1 into 10 to the power of minus 3 meter per second, and E has to be found. What are the other values available? Rho available, R available, I also available. Yes. Current 5 amperes. I is equal to 5 ampere. Using the three values, rho I R. I R. See, remember, when R is given, bring area here. I and A will give you the current density, right? then J is equal to sigma E. We need E, 1 by rho is sigma. So sigma is nothing but 1 by rho. J is current I by A is pi r square, right? Simple, right? So mu is equal to Vd by E, Vd by E is equal to J by sigma. So otherwise we can do it separately. I by A let me put here only. E is equal to J by sigma. J is equal to I by A. This is A sigma. E is equal to A sigma. Is equal to Vd A sigma by I. Right? Mu is equal to Vd by E. E is equal to J by sigma. No, here not sigma is given. Resistivity is given. Yes. So it must be written in terms of rho. Sigma is equal to 1 by rho. Sigma is equal to 1 by rho. Rho is given, not sigma is given. So I must write I rho by A. This is I rho by A. E is equal to I rho by A. Vd A by I rho. Vd A by I rho. Yes, we will substitute the values. Vd is equal to 1.1 10 to the power of minus 3. Area pi r square, pi 3.14. R value 5 mm. 5 into 10 to the power of minus 3. Another 5 into 10 to the power of minus 3. R square. I is equal to 5. Rho is equal to 1.7 into 10 to the power of minus 8. So this has to be simplified. I 5 ampere, this 5 will be cancelled. This is 10 to the power of minus 8, 10 to the power of minus 3, 10 to the power of minus 3, 10 to the power of minus 8. So minus 2 is now available. Minus 2 if I take here, this will be 10 to the power of minus 1. Yes. 3 plus 3 plus 3 9, but I am here, I am having only 8, right? 10 to the power of minus 1, right? Let us rewrite it as 1.1 into 10 power minus 1 into 3.14 into 5 divided by 1.7. This has to be simplified. 1.7, if it is 3 some approximation, right? We will approximate it and quickly get one result. Then we will find the closest answer, right? Let me assume it as 3.4. Instead of 3.14, I am assuming it as 3.4. So that 1.7 and 3.4 can be cancelled, right? 1.7, this is 2. Then 2 into 5 is 10. This 10 power minus 1 and 2, 5 are cancelled. Yes. The answer is 1.1. So we have to find the nearest answer with 1.1. 1.8, 1.5, 1.3, 1. We are having two answers. Yes. 1.3 is also the nearest answer. 1.1 is approximate answer. But 1.1, 1.0, 1.3, both answers are close answer for this answer. Right. We have to choose the correct one between these two, 1 and 1.3. Yes. So what we have done is, we have made 3.14 as 3.4. We have increased the numerator value. 3.14 has been increased in the numerator value. So the answer will be at higher end. This is at higher end. 3.14 has not been assumed as 3. 3.14 can also be assumed as 3 if the convenience needs. But 3.14 we have assumed it as 3.4. We have taken to the higher end. So the answer should also be at higher end. The 1.1 is the bigger number. So the correct answer should be less than 1.1. Then 1 should be the answer. The accurate answer must be lesser than 1.1, because after assuming this 3.14 as 3.4, we are getting 1.1. 1.1 is at higher end. So we have to decrease the value. To get actual value, the actual value must be lesser than this 1.1. So, clear? So the answer is 1 meter square voltage second. Find the current density for an aluminum conductor having drift velocity of electrons. Vd is 5.6 times 10 to the power of minus 4 meter per second. Conductivity sigma is 3.0 into 10 power 7 Siemens per meter. The conductivity unit is ohm per meter or Siemens per meter. Not ohm, mho. Mobility of electrons 0.0014. 0.0014. The question is to find the current density. Current density we have to find. J is equal to sigma E. Sigma is available, we have to calculate. Direct formula. J is equal to sigma E. Sigma is available. E we have to find. E is equal to, from mu and Vd we can write E. Vd is equal to mu E. So E is equal to Vd by mu. Sigma and Vd by mu. J is equal to sigma. What is the value of sigma? 3 into 10 to the power of plus 7. Vd 5.6 into 10 to the power of minus 4 divided by mu 0.0014. 0.0014, let me write it as 14 into 10 to the power of minus 4. Yes. Decimal point I am removing. 14 into 10 to the power of minus 4. So that I can cancel these two terms. 14 into 5.6 has connection. 4 into 14 is 56, but it is 5.6. So this is 0.4. So the answer is 1.2, 0.4 into 10 to the power of 7. All are 10 to the power of 6. 12 into 10 to the power of 6. Current density ampere per meter square. So actually this meter square, the unit is option C. The mean free path of electrons in a metal is 4 times 10 to the power minus 8 meter. The electric field which can give on a average 2 electron volt energy to an electron in the metal will be mean free path what is mean free path, right? So in the concept itself we have defined what is the relaxation time. The electrons, when they are moving inside the conductor with some velocity, they collide with positive ions. Electron comes, positive ion, first collision, then second collision. The average time interval between these two successive collisions is termed as relaxation time. Then the distance, the average distance is mean free path. The average distance traveled by an electron between two successive collisions. Average distance traveled by an electron between two successive collisions. This is written as lambda. Mean free path is written as lambda. So meter, time is tau is in second, right? This is meter, mean free path, right? So the mean free path of electrons in a metal is, it is given 4 into 10 to the power minus 8 meter. The electric field which can give an average 2 electron volt energy. Electric volt, the electric field value we have to find. The electric field is giving energy to an electron. Will an electric field give energy to an electron? Yes. Let us see it. This is our conductor. Voltage we are giving L. V by L is V voltage per meter. This end is plus and this end is minus. The electrons moves in this direction against the direction of electric field, right? That means it is moving from lower potential to higher potential. The electron is moving from lower potential to higher potential, so it gains energy. The movement is lower potential to higher potential. The movement is from lower potential to higher potential. In fact, the field is doing the work, but it is not negative work, right? So we have studied if the field does the work is negative work, but here the electrons are having negative charge. If it is a positive charge, that definition is correct. If a field pulls a positive charge, it is negative. But here it is electron, negative charge, right? So work is also positive, that is why it gains. Don't confuse, right? So this point is clear, right? You can remember this point. Whenever a particle moves from lower potential to higher potential, it gains energy, right? So this is the concept. For solving the problem, the work done is given W is equal to what we have seen in the topic electric potential. W is equal to Q into delta V or simply V. So to move one electron between one voltage potential difference, how much work to be done or how much energy is gained. So W it is given as 2 eV. Instead of Q I will write E electrons. Then V. E and E are cancelled. So voltage is equal to 2 volts. So from here I am getting V value is 2 voltage. The question is E. E is equal to what? E is equal to V by L, but in this case instead of L we must write not L, lambda we must write. Mean free path. Between these two collisions only, how much energy it is gaining, that is the question, right? You should not write L here. In fact, L value is not given. So V is equal to 2, lambda is equal to 4 into 10 to the power minus 8. This is 2 by 4, 1 by 2. So 0.5 into 10 to the power minus 8. So that is the answer. 0.5 into 10 to the power minus 8. 10 to the power plus 8. When it goes up, it is 10 to the power plus 8. Hmm. 5 into 10 to the power 7. Yes. The electron moves from lower potential to higher potential. It gains energy. The electric field is giving the energy. When it loses the energy, when it is collided with the positive ion. This will be detailed studied when we discuss the topic resistivity, right? So in the next video we will be seeing resistivity, the origin of resistivity and related few problems, right? What is resistance, how resistivity comes, then conductance, relevant problems, right? So this is the end of this video lecture, right? Thank you for watching this video, viewers, right? Good luck to you all. Yes, thank you for watching it.